when it's set up like this, they're setting it up because they want you to do the u substitution. They want you to realize to take the derivative of this. If you realize you can just take the derivative of this and then multiply by u prime, then you can get the derivative using the chain rule. What else could you do? You could take this, and everywhere you see a u, you could replace it with pi x, and then you could just do the chain rule as you go. That's also an alternative. The one in our notes yesterday, I think would have been awful to do that with. This one that isn't that bad to do, that you could do that. But what they want you to do is they want you to realize that to find the derivative of this, you can really just find the derivative of this whole thing, which I'm going to say is f prime of u, and then multiply by u prime. So if I was going to take the derivative of this, we want to leave that as 1 over cosine squared. Sounds terrible, right? First of all, could I rewrite that as u plus cosine, 1 over cosine is the same as secant squared? Is that true? You would have just said cosine to the negative 2? Yeah. I think it's true we want to use the reciprocal though, right? Cosine is secant. Yeah. So we could say that's the same as secant u squared. I'm going to put the squared on the outside. You could do the quotient rule here. You'd get the same answer. But now that we have the chain rule, like we could do the chain rule here, right? Oh, that's kind of crazy. All right, so what would be the derivative of u? 1. Plus, if I did the chain rule here, could I bring that 2 out front? And then that would stay secant of u times the derivative of the inside. What is the derivative of secant? Secant x tangent x, or in this case, secant, oh, that's not secant, secant u tangent u times u prime, right? Because we have to do the u prime where this is u. So if u equals pi x, what's the derivative of pi x? Just pi, because it's just like if it was 3x, so then I also have to say times pi out here. If you substituted pi x in there, then you should have x, like everywhere that there's a u here, that would say pi x, right? That would be the difference of what we have here. What do we need to do? We need to substitute in what is u when x equals 1/4. So again, just like we did yesterday, we could say u equals g of 1/4, which would just be pi times 1/4, or that's just pi fourths. Right? And so now that's what we're going to plug in here for u to find the derivative at that point. So we can say f prime of pi fourths equals 1 plus 2 times, that's really secant squared, so I don't know how you want to write it. I'll just say secant of pi fourths times secant of pi fourths times tangent of pi fourths, all times pi because of that u prime. Alright, so this is where our trig comes in. Pi fourths is right there, halfway between the first quadrant there, and we know that the ordered pair is radical 2 over 2, radical 2 over 2. So tangent of pi fourths is my favorite, right? Because tangent is y over x, so tangent of pi fourths is just 1. But what would secant of pi fourths be? Right, because secant is the reciprocal of cosine, so if you flip that over, that's the reciprocal, and then if you rationalize that, you would get 2 radical 2 over 2, which is just radical 2. So we get 1 plus 2 times radical 2 times radical 2. Tangent of pi fourths is 1 times pi. Radical 2 times radical 2 is just 2 times 2 is 4. So I think the answer is just 5 pi. Again, maybe it's just easier to plug it in that one and not do the whole times u prime, but they're trying to like force you to do that. And sometimes that happens on the AP exam. There was a question on the 2014 AP exam that really stumped me, and it was because they wanted you to do the whole dy over dx equals du over dx times dx over dy, or I don't even know. But I don't think of the chain rule that way, and that question like forced me to think of it that way, and I missed it, and I was grumpy about it. So that's why this book. That's why I like this book, is because they really do try to prepare you for the AP exam. I used to. The 2015 one has already been released, but I haven't taken it yet because I'm drowning in life right now. But yes, I take them and then I grade myself, and then I go back and try to figure out what I'm wrong, and then I can't figure it out, then I try to find someone that can figure out what I can't figure out. Normally, if I keep track of which ones I missed, so that when you guys take it, I can tell you which ones I missed and why I missed them, so that you can see like it's so easy just to make silly algebra mistakes. Or one time it said find where the function's increasing, and I totally found where it's increasing, but then I circled the answer where it's decreasing. So I always like write down my mistake of what I missed, and then usually it's like dumb mistake next to it. Or yeah, so yeah, it's really cool because they used to only come out every like 4 years, and now I have chosen 3 exam, 8 exam, 12, 13, 14, and then the 2015 exam. But I haven't taken it yet, so lots of stuff to practice. You want to look at another one of these? 29, 21. Okay, so again, on the trig ones for me, I like to write it with that 2 on the outside. It really helps me, especially when I first started doing these, right? Because this is like sine of 3x minus 2 squared, like the whole thing is squared. So I feel like sometimes if you look at the way, it's nice to write it like this, but when you try to take the derivative like that, sometimes you forget what the most outside function is. But when you write it like this, it's easy to see that 2 is out there. So then you would be left with sine of 3x minus 2 to the first power, which you only need 1. And then, so this is like a lots of layers, right? So then the next layer would be taking the derivative of sine, and the derivative of sine would be cosine, leave the inside alone, right? So I took the outermost layer, chain rule once. Second layer is taking the trig function, leave the inside alone, and then the third layer is going back and taking the derivative of the inside, which is multiplying by 3. Right, so it's really easy for that to happen. So I think the answer should be 6, and then it's whatever order you want to write that in. Sine of 3x minus 2 times cosine of 3x minus 2. And this is a really good example of why you need parentheses. If you didn't put parentheses around this, cosine of 3x minus 2, right, that's different than this, because if you don't put parentheses around it, then it's cosine of 3x, and then subtract 2 from the whole thing. So really important, especially with addition and subtraction of trig functions there, that you put parentheses around those. Oh, they are using a trig identity, I bet, right? So this is where calculus likes to remind you. Remember all those trig formulas you learned? Something like this? Isn't that an identity? Sine of 2x equals 2 sine of x cosine of x. Maybe. So they had it as 3 that sine of 6x minus 4, because that's like 2 times 3x minus 2 would give you the 6x minus 4. On the AP exam, I've never seen a question that they make you do a trig identity like that. What they do expect you to know is sine squared plus cosine squared equals 1. But in the book, sometimes they like to give you ones, and that's why I like for you to check in the back of the book, because it kind of reminds us all of, oh crap, I was supposed to remember that. So that's the thing. If this was on a test, I would count that, right? There was actually one on the test that I just gave back, that there was one of them that you could simplify. Like I wrote like bonus, if you remember the trig identity, it was on the first page. I forget which one it was. But I wouldn't mark it wrong. But that's why I didn't match the back of the book, because they're using a trig identity that you haven't learned yet. On number 6.
I just keep forgetting.
And on this one, this is where they gave you the u value if you wanted to use the u substitution, where you can plug in u and then multiply by u prime. But this is just our inside function there. So 5, and this is our outside function. So what is the derivative of cotangent? Negative cosecant squared, right? So all the c functions start with negative. I always know the derivative of tangent is secant squared, and so that's how I remember the derivative of cotangent is negative cosecant. Let me those go together. So I'm going to change this to negative cosecant squared. Leave the inside alone. Right? So that's my inside function. Times the derivative of the inside, or in this case the derivative of u, and if it helps, write that up as 2x to the negative 1. So your derivative of that would be negative 2x to the negative 2. So I'm just going to write that as negative 2 over x squared. Might as well move that back down. So negative 5 times negative 2 is 10 over x squared cosecant squared of 2 over x. And really the cosecant squared, like it could all be in the numerator. It just kind of depends on how you want to write it there. But definitely the x squared should be the denominator.
Can we mark it wrong and put negative x squared on the top instead of
X to the negative 2, you mean?
yeah.
It's okay. For me, if it's just 1, I don't think it's that much trouble to move it down if there's no addition and subtraction. But unless I multiple choice, this would be an AP multiple choice question, and that's the big thing about checking answers that are odd. I know this one's not odd. Is just try to make sure that you're matching when they simplify it. So I wouldn't mark it wrong, as long as you had the negative 5 times 2 is 10. Okay. Okay, the notes are pretty short today. That's exciting, right? I just don't know what we're doing after today, so. You know the senior cookout this Friday? Did you know this? Good news, it's not first hour. Third and fourth hour. Which means our quiz that was going to be on Friday is now tomorrow for third hour. I think yes, because you have to go get your picture first, and then I don't really know. At the meeting this morning, all we got told was senior cookout Friday. So
supposed to do an essay every day.
Mr. Love would be the one to ask, or Mr. Schiff, or Mr. Gardner. It's either of them.
I was sure I could say.
Sorry.
Okay, so the other thing they throw in here to the chain rule is they talk about parametric equations. Do you remember parametric equations? We did them in pre-cal already. We just didn't do them with trig. But it's where you have the 3 variables. It's where you have like x equals sine of t, y equals cosine of t, and then you graph them at the same time, and you have 3 variables. Remember we did that in pre-cal, but not, or you're not in pre-cal, you're in pre-cal. We just did it, we start out in pre-cal with doing it with not trig functions, and then second semester pre-cal, we do it with trig functions, and we can graph circles and those rose curves. Remember that in pre-cal from last year? When we graphed these lovely things? And we graph things like this. Whoa. So there's a lot of stuff you can do with parametric equations in calculus. We're not going to touch, we're not going to go in depth to any of it. But they just want to show you that if you have parametric equations, which is where you have 2 equations written with t in them, that you can also take the derivative of it. And the derivative, it says if all 3 derivatives exist, kind of complicated there, but the derivative of dy over dx is just taking the derivative of dy over dt all divided by dx over dt. This is where I think it's helpful instead of just writing y prime, because if you just wrote that, it's kind of tricky to see how it all matches up here. But if you want to take the derivative just with respect to x here, think about if you simplified this, dy over dt. Sorry, you're probably still writing it. I forgot this. And if you divided by dx over dt, dividing by that is really like flipping it up, right? So the dt's actually just cancel out, so that's why it equals dy over dx. It just means if I gave you two functions, like y equals sine of t, x equals cosine of t, if I wanted you to take the derivative of those, you really just have to take the derivative of the y function divided by the derivative of the x function, and that gives you the derivative of the parametric curve altogether. Which means, unfortunately, for our two newest members of calculus, there's a lot of trade-offs. Or maybe fortunately, because it gets you to practice that, right?
We didn't start doing trig until out of class.
I know. The day that I convinced Adam to come to my classes, they were like, let's do trig every day. So, that's all right. It's like immersion. You know what they say, like, if you move to a country and you don't speak the language, like, you just get immersed in it and eventually you learn it. Like, that's what we're going to do with trig. We're just going to keep doing it every day and eventually they'll just absorb it. And soon we'll be doing trig all the time. All right, let's look at an example. Oh, tangent line even. Find the equation of the line tangent to the curve at the point given by the value of t. X equals 2 cosine of t, y equals 2 sine of t at the value of pi force. And maybe even after we do this, we can look on the graphing calculator of what does this look like when I'm doing it. So remember, maybe you don't. Chloe's walked out all freaked out. Parametric curves are usually not functions, like they usually don't pass the vertical line test, and so that's why it's easier to write them as x equals and y equals, because if you tried to write it just as an y equals equation, it's not very pretty to do. But if I wanted you to do this, right, this would be without a calculator, I would want you to find a tangent line. What do you need to find a tangent line? We need a derivative because we need a slope. So we need a derivative. So our derivative is the new thing, right? So the new thing is that to find the derivative of a parametric equation, we're going to take the derivative dy over dt, that's the y equation with respect to t, divided by the x equation with respect to t. And the good news is, compared to all the crazy stuff you did yesterday, these aren't that bad to take the derivative of. What would the derivative of 2 sine of t be? 2 cosine of t. And what would the derivative of 2 cosine of t be? Negative 2 sine of t. And we could say the 2 canceled out. And if they didn't give you a point there, right, if they didn't give you pi force, and I just wanted you to give me the derivative, I do expect that you simplify your trig. What is cosine divided by sine? Cotangent? Yeah. Sine over cosine is tangent, so cosine over sine is cotangent. So, again, I need to do like a trig 101 for our new people. But since they just said plug in pi force, you could have just plugged in pi force here and you still would have gotten the same answer. I seriously took this whole basket home last night, so I was like, I just put everything in the basket and I was like, I'm just gonna grade this. And then no one did let me, and then I got the 430 to grade it, and I put it graded, and I graded 0.
Thank you.
That's right, I got all breaks to grade all right.
Not great.
Yours aren't due till after fall break. So. It isn't at least it's Friday, but you guys don't get your report card until you come back. So all's well. Since they give me pi force, right, I'm gonna do negative cotangent of pi force, and again, tangent and cotangent, pi force is my favorite angle because it's just radical 2 over 2, radical 2 over 2, and if it's just sine over cosine, cosine over sine, what is the cotangent of pi force? 1, because there's a negative in front, it's negative 1. Right? So that's my derivative, which is my slope of my tangent line. Definition of a derivative, the slope of the tangent line. What else do I need to write a tangent line? A point. Normally they give you the x and you just have to plug it in to find the y. With parametric equations, they give you t. Can we find x and y if they give me t? Yes, because if they give me t, all I have to do is plug that in for x and y. Plug it in for t to find x and y. So I need a point, right? I need a slope and I need a point. So for my point, I'm going to say x equals 2 times cosine of pi force, and y equals 2 times the sine of pi force. Cosine and sine of pi force is just radical 2 over 2. So 2 times radical 2 over 2 is just radical 2, right? 2 times radical 2 over 2 means that the point is radical 2, radical 2. So this is where point slope form is amazing because we don't have to simplify this. Write an equation of the tangent line. So point slope form, I can say y minus radical 2 equals negative 1 times x minus radical 2. And that is an acceptable answer. You don't have to simplify it. You could, it's not that bad, but you don't have to simplify it. So writing tangent lines is never going away. On your AP exam, 100% you're going to have multiple choice questions about tangent lines. You're going to have free response questions about tangent lines. And every time we learn a new skill with derivatives, we're just going to practice writing tangent lines using that new skill.
Are derivatives something that we're gonna learn new things about all year?
First semester is all about derivatives. So the next chapter is called applications of derivatives. And then second semester is all about integration, which is like undoing derivatives. And that is calculus. I don't know. I think second semester because first semester is like you have to get your brain in calculus mode, right? Like it's a whole new way of thinking. But there's some really cool things we learned second semester, and by cool I mean sometimes complicated. So, but we finish new material by spring break-ish, because then we'll start AP review after that. So that's another reason I think second semester is easier, because really just January, February, March, we do new stuff, and then we just review everything for April. And then you can be. Then you're done with me. All right, you try this one. It's not even trig. Oh wait, I was going to graph that other one for you. You write this down, and then I'll graph the other one. The one we just did, so you can see what a parametric curve looks like. But not this one. This one's not circle. Yeah. Same as the last one. Find the tangent line using those functions, and then I'll graph the one we just did while I hold an AS. How many more do you think I'm doing? How many copies? She wants to for 100. So I should make 100.
75?
Okay, everybody write this down? And then when you get it done, compare with your neighbor and see if you agree or disagree. Very quick interruption to you're doing calculus. Remember that to graph parametric equations on a graphing calculator, you just go to mode and you change it to parametric mode. So then when you hit y equals, you have your x equals and your y equals equation. Was it 2 cosine? I forget. 2 cosine 2 cosine. Whoa.
I wrote X with the last paragraph.
So, real quick, to interrupt your new problem that you're on. If you graph x equals to cosine t, y equals to sine of t, you actually get a circle centered at the origin with a radius of 2. That's where the 2 came from in there. So we found the tangent line at pi force. So what if we drew or wrote our tangent line in there? What was our tangent line? Oh, how do I do that on this? I don't know. Anyway, it's a circle. All right. So y first, right? So if I just wanted the derivative in terms of t, it would just be t squared. But since they give me -1, we get that it's just a slope of 1. Then at -1, x is just going to equal 2. Y is just going to equal 1. What's wrong?
Wait, I have x equals 5.
Oh, look, I didn't add 3. I just did 2t squared. Whoa. Well, that's interesting. Oh, how do I fix this? I did 2 plus 3 is 5. Sorry, I didn't look at the 3. That's one of those mistakes that makes you really mad when you realize that. So y minus 1 equals 1 times x minus 5. So if you wanted to graph that, really, that would just be right. Yes. Questions about that? Just remembering the derivative is really the new thing. Like remembering that you have to do the 2 derivatives. But that's it. Look, that doesn't get any worse than that today. Which means if you didn't get yesterday's finish, because there's a lot more yesterday, or if you have other questions about yesterday, go back and look at that. And so you're just doing 42 through 48 multiples of 3, and then a few others. 42, 45, and 48 are just like the 2 examples we did. Find the equation of the line tangent to the curve. I would like you, well, 45 is the only odd one, but check the back of the book, and if they write it in slope-intercept form, you write it in slope-intercept form. That's the kind of stuff I want you to start doing. And then 63 gets us into good old velocity again, and then 72 and 73 are some multiple choice. And notice, on the multiple choice, they always tell you whether or not you can use a calculator, and it says no calculator. So those are kind of good practice. I'm not sure what we're doing the rest of the week, so we'll find out tomorrow. Whether or not I can
Take a stack of those lines.
The thing is, it's not even sorted. There's a lot of test corrections in there. I don't even know what else is in there. So. If you freak out homework that's graded, I just have to record it. And I'd be able to do it. I did read 63 pages in my math history book of the grad class I started. And I have a 15-minute video. History of math, that's what it's called. So, like, could you write that as a power?
I put that on this one, and that's not what practical is.
Well, what was your U this is right,